Thanks, everybody. So I won't bore you by reading out everything that's on the list here, but this is what we're going to be going through today. I just want to point out that we're not really like dropping any zero-day or anything directly exploitable. This is more a bit of an informational talk to give you some tools and techniques that you can use if you do run into something that discloses Java heap memory, then how you can extract sensitive information from it. And it tells a bit of a story about how we got there. So just a little bit of an introduction on us. We test pens for a company called Trustwave Spider Labs, mostly biros and quills, but we're more generalized than that. Yeah, Brendan and myself both work for the Spider Labs delivery team in Asia Pacific, and quick plug, we are hiring if anybody would like to join us testing pens. We both have a bit of a coding and development background, so more on the AppSec side, and do a lot of web app pen tests. And the way this came about was Brendan did a web app pen test against an app for a bank, let's just say. I won't be more specific than that, but something that's potentially very sensitive for a bank. It was a Java-based web app, and then we run a quality assurance process against all of the tests that we do. So I was assigned to do QA on his test, and the night before, I'd just been drinking too much coffee or something, and I'd gone and installed a shitload of burp plugins. And I was like, let's just try this out for this QA process. I'll get his target, get a request, and just fire off all these active scan plugins and see what I get back. And sort of 2,000 requests later, I got this really interesting issue. So here's a screenshot of it. Obviously, I'm redacting the target. But I'd never heard of it. I've been doing Java security for 10 odd years, and I thought I'd heard about all the different vulnerabilities, and then this came up, and I'm like, Spring Boot Actuator. I know what that is, but how is this a vulnerability? I'd never really heard of it before. So it turns out Spring Boot Actuator is Spring is a major web app framework for Java. Spring Boot is part of that framework, and Spring Boot Actuator is like a instrumentation and management plugin. So it gives you an admin interface where you can do a whole bunch of sort of instrumentation activities against the app that's running. And one of the things that it allows you to do is download a snapshot of the heap memory, a heap memory dump. This was exposed without authentication. It's just basically a configuration error. The person's added it to their POM and then not specified any kind of authentication or authorization. And it's a common enough issue that in this burp plugin, it's just something they look for in a URL signature. So I thought, okay, well, if you've got the whole snapshot of heap memory, it's game over, right? Because anything sensitive in there, the keys, like encryption keys, passwords or whatever, surely you can extract that from the heap memory. But so were I reporting this as a security vulnerability, normally you'd sort of stop there and go, so in theory, I could extract anything from memory. That's all I need to say, report the vuln. But because it was a penetration test, we wanted to go further than that and show what can we actually get from memory, and how do we do this? So, step back for a second to how Java actually manages memory. So, at runtime, the only thing that a developer controls is the heap. The stack is defined at compile time and is not controlled by any user-defined code. All of the objects that you instantiate into memory and then get reaped by garbage collection are all stored in the heap. So basically, everything in the application is in the heap. And the way that it works is things sort of graduate. So Eden, like Garden of Eden, is where when you instantiate a new object, it goes into that area of memory. And then there's these minor garbage collection cycles that come along and say, oh, there's no longer any references to this object. I'll just reap it and remove it from memory. But if over a period of time there's still references to it, it gets put into progressively older and older parts of memory until it winds up in old memory where it's very rarely checked. So rather than constantly looking at it saying, is this still referenced, is this still referenced, I want to garbage collect you, it sort of makes the assumption this is probably around for the life of the execution. So that's not particularly important, but what it means is that everything that's ever in memory will be in these snapshots at some point in time, but it is ephemeral, it's time-based. So you might have encryption keys or credentials that get instantiated at a point in time and then get garbage collected, and you'd need to collect the snapshot at the correct point in time to get them. So the other thing that's relevant here is JMX and JConsole. So this is native, JMX is the Java management extensions. It's native to the Java platform for doing instrumentation of and debugging and so on of running applications. And it allows you to directly manipulate execution at runtime. So you have mbeans, which are managed beans, which are particular classes that conform to a contract inside the running application. And then using JMX, you can connect to the process and start directly instantiating objects, running methods on them, etc. And this is something that we found really useful for interacting with running applications to get memory snapshots at particular points in time or manipulate state. It's also something where you might not be able to see it too well on the slides. By default, it's only bound to local PIDs, right? So this is JConsole, which is a JMX console tool. And by default, you can select all of the local processes that are executing in the context of your user. If you're root, you'll see every process running by anybody. But if you look down the bottom there, it's also got remote processes. So you can bind JMX to an RMI port or an IIOP port, and then it will be exposed over the network, potentially with authentication, doesn't really support SSL properly. So this is something that is often done on the back end. I've seen a lot of application servers that are in clusters or so on, where on the back end, they will be exposing JMX over the network, and the only thing stopping it from being publicly accessible is the firewall. So once you get some kind of foothold in the network, this is something you should be looking for, remote JMX. And once you have access to JMX, you have complete control. You win. So that's just a bit of an aside. Okay, so that's all the building blocks. Then we're going to talk about how you can actually obtain a heap memory dump. So there's a variety of ways that you can do this. And as I said, I'm not really just putting out, oh, here's this 0-day way to get a heap memory dump and now you win. It's more there are various scenarios you might encounter where you can do it. And then what can you do once you get it? So the first one is using JConsole. And this is probably the easiest way if you just want to play around with this at home, is you just run a Java process, connect JConsole to it, and then you probably can't see too well on the screenshot there, but there's some built-in classes on the class path, including one that allows you to just dump the heap as a method. So I've filled in there as parameter 0 a path to a file name, and when I hit execute on that, it is going to write out that memory dump. We'll have a live demo of that in a minute. The second way is, as per the issue that sort of spawned all this research, the Spring Boot actuator, so /heap dump. I'm sure you can do some Google Docs and find public instances of this, and it's just going to immediately deliver you a gzipped version of the memory dump. And then there's more creative ways, like have a look on GitHub. Seems like quite a common scenario that people just commit everything in their working directory, and then they go, oh, that 80 meg memory dump, I probably want to delete that. So you just go back to the previous commit, and you can find quite a lot of these on GitHub. So with that, I'll hand over to Brendan to do a quick demo on how you can do that.
Cool. Cool. So as David said, there's quite a number of ways to obtain a heap memory dump. I'm going to go through just using the Spring Boot actuator and using JConsole to do the dump. So here I've just got a basic Spring Boot application that has actuator enabled. It just says like a hello message. So if we go, interesting with actuator, if you go to /actuator, it actually gives you a list of all the endpoints that are actually enabled on the server. So there's some really interesting ones like /beans, health, shutdown. So you can actually gracefully shut down the server. /env, so you can dump all the environment variables off the server, which during our engagement we actually found SSH creds into other external facing services, and the heap dump. So if we just go /heap dump, as you can see, yep, just downloads onto your file system, and then you can analyze that. It's important to note, though, with Spring Boot actuator, it is by default requiring authentication, but it's not uncommon for that authentication to be disabled because developers like to make their life easy, and if they're testing and doing development, they don't want to keep entering creds using this. So in our instance, that config that the developers have changed got pushed into production, and we were then able to access all these endpoints. So the second way of doing this is using the JConsole. So as David mentioned, we got all the classes in the class path here. So we just go down into the com.sun.management, hotspot diagnostic, operations, and we've got a few functions here that we can call, but the one that we're interested in is in dump heap. And in here, we can just enter in for parameter 0 the path and file name that we want to save this heap dump to. So in this instance, we'll just go /temp/yolo swag.hprof and dump heap. And we get a message saying method successfully invoked. And if we then go to, say, our /temp, who knows what I've got in here? So we can see that we've downloaded YOLO swag. So yeah, with these memory dumps now, we can use some tools to analyze those further.
Awesome. Okay, so yeah, the next step is, so now you've got a heap memory dump, now what can you do with it? That screenshot's not going to render properly, but that is just to show you that it is a completely binary format. Just running strings on it or trying to analyze it without any tools is a pointless endeavor. So the format is hprof, which stands for heap profile. It can contain some CPU instrumentation data as well, but generally by default, it has the list of all the objects and counts of instances of that type of object, the per object memory usage, and then most importantly, it has all of the instance member data. So everything that's actually stored in memory for instances of a particular class, you can extract. The binary format is a standard that's specified in the JDK documentation, so there are multiple tools that you can use for analysis. Android Studio, there's a little bit of a subtle format difference between general hprof files and Android hprof files, because obviously Android apps are Java apps, but you can convert between those two formats easily. So you can use Android Studio not just for Android memory dumps, but for general Java apps as well. There's commercial tools. YourKit Java Profiler was the one that kept coming up for me. So I'm not going to pay for it. And then there's JHAT, the Java Heap Analysis tool, which is part of the JDK. It's been around since, I think, Java 1.5 or something. It's very old, it's very stable, and it's the reference implementation. So that's the main thing that we used. You can see there in the screenshot, when you run JHAT against a hprof file, what it does is parse that and then expose a web app on a local port, and that web app is the GUI, is the analysis tool. Interestingly, it's got this OQL, object query language, that allows you to do searches. So if you've got a complex heap dump and you just want to find instances of a particular class type, or you want to look for certain strings in member data, you can do that using OQL. And none of the other tools that I saw really give you that, that kind of capability. So this is what you get. This is a screenshot of the web app that JHAT renders for you. This is when I just ran a Hello World application. So the only user-defined or programmer-defined class was Hello World and a single instance of it. So that's all you see. But if you have a more complex application, you will see everything in the heap there. So I'll hand over to Brendan to do a demo of how you actually extract that data.
Cool. Yeah, cool. All right. So yeah, so we've got the memory dump now. What do we do with it? So just to kind of demonstrate the whole process of like an app, I've just created a very basic Java application. I'm not a Java dev, so most of this code is just copy-pasted from Stack Overflow. So write my best code from that. So yeah, okay. So we've got a we call the load user function that's inside this utils class. Stores it in the admin account object, and then we run on an infinite loop, ask the user for their username, ask for the password, and if the username and password match what we loaded in from the utility class, then we say, welcome back, username. Otherwise, we just give them a nasty error message saying bad login credentials.
So this is just an example to demonstrate capturing sensitive data in memory, i.e. the credentials. Yeah. It's not designed to actually do anything useful.
Yeah. Our user class, so our user objects just have two properties, a username and a password. And our utility function, the load user just instantiates or creates a new user object with some obfuscated username and passwords. This is just to demonstrate like running strings on this is like gobbledygook, so the username and password's only available in memory during runtime. So yeah, that's to just sort of demonstrate that we don't know what the well, we do because we've got the class here, but in real situation we won't. So first step for that would be to go over back to JConsole, and we bind to the local Java process running with the jar file, and we repeat the same process that we just did. So we just go over to mbeans, go back down to the dump heap function, and in here we're just going to go /temp /newt.hprof and dump heap. So now that we've got a memory dump, we can use jhat to load this up so we can browse it. So jhat temp. So jhat's gone and run its magic, and it's grabbed all the objects and classes out of that memory dump. It starts a local web server on port 7000 by default. You can't configure that. So that was really fast. In a real environment, the dump files are going to be much larger, and that's actually going to take quite a while to finish and start that server up. So
I think it took about a minute with the prod dump that we had, yeah.
So if you play along at home and it's taken a while, that's expected. So then with that, if we go over to localhost on 7000, so here we can see that we've got jhat's pulled out the Crikeycon class, the user class, and the utilities class. So because in our demo we don't know what the username and password is, let's have a look in the user. Yeah. So inside of the user class, we can see that we've got references to the username and password properties that were defined on that class. And we can also go down here and find all the instances to that class. So if there's multiple user objects or any objects that you're looking for, it'll list all the instances of those here, so we can manually then browse to each of these and see what data is assigned to it. So if we open up this, we can see, we can have a closer look at this user object, and we can see the username and password properties, and they've got hexadecimal values to it. So what we'll do is we'll just copy all this, and we'll come back over to Adam. So I'm just going to format this in a slightly nicer way, so we can use Python just to bring that back to a normal string. So we'll just quickly get rid of that. And replace that, and just remove those white spaces and commas. Cool. So looking back here, so we know so the bottom's a username, so we need the username to be able to log in. So we'll just. So
the reason it's formatted like this is Java, like C, a string is just an array of characters. So that's just showing the individual character data in hex.
So using Python, we'll just print in a string these hexadecimal values, and we return droppy. And if we do the same with this password, we should receive the plaintext password that was. That's not going to work. So we can see that the password for droppy is holy moly cheesy guacamole. So if we copy that, and just to prove, so we'll try using these credentials now to log into the application. And we get welcome back droppy. So we successfully extracted the username and password from that memory dump during runtime.
Awesome. So yeah, that's all we had. It was a pretty straightforward presentation. Just to recap, I thought this might be something that's useful for your toolbox. If you ever run across a memory dump, there's tools you can use to analyze it. And if you ever see Spring Boot Actuator across your screen, definitely take a look. I was talking to Shubs earlier, and he said he's seen it in prod as well. So it's definitely a real issue out there. And yeah, anybody have any questions or comments? No, everybody just shocked and awed. Awesome.
I think you guys are still the only guys that are willing to get down and dirty with Java. Everyone else just ignores it. So, can I get a round of applause for David and Brendan, please?